Hello students, I am Dr. Ritu Agarwal from ABES Engineering College. Today I would be teaching analysis and design of combination circuit for the lecture series Digital System Design. In this series, first of all, we will start with the analysis procedure of combination circuit. So how we can analyze a given circuit. There are some specific steps for that. The analysis is to determine the function of an implemented circuit. Means that if a circuit has already been implemented, we have to analyze the circuit and we will determine the function of that implemented circuit. So this task starts with a given logic diagram and culminates with a set of Boolean functions, a truth table, or possibly an explanation of the circuit operation. That means if a circuit is being given to you, that is a logic diagram is given, then we will find out a set of Boolean functions or we will find out the truth table, and then we will explain that circuit or the operation of the circuit on the basis of Boolean function and truth table. The analysis can be performed manually by finding the Boolean functions or truth table. So the first step in the analysis is to make sure that the given circuit is combination circuit. Now, how we can make it sure that it is a combination circuit? The main thing is that the combination circuit has no memory element. That is, it is simply a combination of different logic gates and it does not have any feedback path and it does not have any memory element. So once we are sure that it is a combination circuit, it does not have a memory element, then we will go for the further analysis part. So first of all, we will label all the gate outputs that are a function of input variables with arbitrary symbols but with meaningful names. Then we will determine the Boolean functions for each gate output. Then we will label the gates that are a function of input variables and previously labeled gates with other arbitrary symbols. Then we will find the Boolean functions for these gates. Now, by repeated substitution of previously defined functions, obtain the output Boolean function in terms of input variables. So now we will understand these steps with the help of an example. So here is an example. In this example, we can see a logic diagram in which this logic diagram comprises of some of the gates, that is AND gate, OR gate, with some of the input variables A, B, C, and the functions as T2, T1, F2, dash, T3, then F1 is the final function. So we have to analyze this function, and in this analysis, we will find out the final function of this analysis. So we can analyze this circuit. First of all, we will see that here is an AND gate. So T2 will be equal to A dot B dot C. Then we have OR gate. So T1 will be equal to A plus B plus C. Then the output of this AND gate will be output of this AND gate will be A into B. Output of second AND gate is A into C, and output of third AND gate is B into C. So finally, these inputs are given to an OR gate. So the output will be AB plus AC plus BC. Then the output of this OR gate is given to a NOT gate. Therefore, this F2 function will be equal to AB plus AC plus BC whole bar. Now, by applying De Morgan's theorem, by applying De Morgan's theorem, we can write it in the manner of AB bar plus AC whole bar plus BC whole bar. Sorry, not B plus, it should be a multiplication sign. So again applying De Morgan's theorem, we have A bar plus B bar dot A bar plus C bar dot B bar plus C bar. And then we can multiply these all the three products or the three sum, that is A bar dot A bar plus A bar C bar plus A bar B bar plus B bar C bar into B bar plus C bar. Then A bar into A bar will become only A bar plus A bar C bar plus A bar B bar plus B bar C bar into B bar plus C bar, which is finally equal to A bar plus B bar C bar plus into B bar plus C bar. And then we can again multiply them, and after multiplying, we will get the function as A bar B bar plus A bar C bar plus B bar C bar plus B bar C bar, and B bar C bar plus B bar C bar will be equal to B bar into C bar only. Therefore, A bar B bar plus A bar C bar plus B bar C bar. So this is the function of F2. Now we come to this part. Here we have T2 plus T1, and from here we have T1 is given to this function, that is T3. So T3 is equal to nothing but T1 multiplied by F2. So here we will have this function that T2 will be added to T1, T2 plus, we can multiply this T1 value, that is A plus B plus C, and this is equal multiplied by, that is T3. What is T3 over here? T3 is nothing but T1 multiplied by F2. So T2 plus T3. So T2 plus T1 multiplied by F2. So here, instead of writing this T3, we will write F2. So we have this function T2 plus T1 into F2. Now we have T2 is nothing but ABC, and T1 is A plus B plus C, and F2 is A plus B plus C multiplied by A bar B bar plus A bar C bar plus B bar C bar, which we have already derived here. That is A bar B bar plus A bar C bar plus B bar C bar. Then multiplying all these, we will get this function, that is ABC plus A B bar C bar plus A bar B C bar plus A bar B bar C bar. So this is the final function. We can call this final function as F3 or F1. So we can call it F1 equal to ABC plus A B bar C bar plus A bar B C bar plus A bar B bar C. So this is the final function for this logic diagram. So this is all about the analysis. We can even draw the truth table of this. For example, if we take the inputs as A, B, C, and we have the inputs as 0, 0, 0. So corresponding to this, we can find out the value of F1. Now, what will be the value of F1? Obviously, it is equal to 0 only, because ABC is 0. Then in the second term, we have A equal to 0. Then in the third term, B is 0. And in last term, C is also equal to 0. So the sum of all the zeros will be equal to 0 only. Then we have 0, 0, 1. So if I have 0, 0, 1, for the first term, we have A into B into C, that is 0. Then for the second term, A is 0. Therefore, the whole, this term will be again be 0. Then A bar, B, C bar. Again, this B is 0. So the whole term becomes 0. And for the last term is A bar, that becomes 1. B bar also becomes 1, and C is 1. Therefore, this terms becomes 1, and therefore the whole function will be equal to 1. So in this manner, we can analyze the circuit by using truth table also, and we can complete this truth table with the help of this function F1. So now we come to another topic, that is the designing procedure. We can even design the circuit or design the combination logic circuits. So this is combination logic circuit are made from basic and universal gates, and the output is defined by the logic, and it depends only on the present state and not on the previous state. So here are some of the steps which we will follow to design a combination circuit. So what are those steps? First step is, first of all, we will define the problem. Whatever circuit we have to draw, first of all, we will have to define the problem. Then for the second cases, we will determine the number of input and output variable. Means secondly, we will find that what are the number of input and what are the number of output variables. Then with the help of truth table, we will find out the relationship between input and output. Then in the fourth case, we will draw the K-map, and with the help of K-map, we will find out the simplified Boolean expression for the outputs. And finally, we will draw the logic diagram using gates. So these are the 5 steps which we will follow to design any combinational circuit. So to understand this designing part in more detail, we are taking one example. Example is that design a combinational logic circuit with 3 inputs where the output is at logic 1 when more than 1 inputs are at logic 1. It means that in case of this truth table, since we are having three inputs, so A, B, C are the three inputs, and three inputs will be having 8 number of combinations starting from 0, 0, 0 to 1, 1, 1. So here we have drawn a truth table in which we have three inputs and one output. And what does this problem says? That output is logic 1 when more than one inputs are at logic 1. Means whenever the inputs are more than one, means for example, if we see the first case was 0, 0, 0. Since there is no 1, so the output is 0. Second case 0, 0, 1. So here we have only 1 as one input. Therefore, the output is again 0. For 0, 1, 0 inputs, only one input is taken as 1. Then again the output is 1. Then in 0, 1, 1. For 0, 1, 1, we can see that the inputs are more than 1. Means at two places we have 1, 1. And therefore the output will be equal to 1. Similarly, for the fifth case, that is 1, 0, 1. In 1, 0, 1, we have two ones. And therefore the output is 1. For 1, 1, 0, again we have more than one ones. Therefore, more than one input is 1, therefore the output is 1. And the last case 1, 1, 1, again the inputs are more than 1, so therefore this will be equal to 1. So this is the truth table which is defined as per the problem. Now we will draw the K map. Now since it is having three inputs, so we will be having three input variable. And how many outputs we have? We have only one output. So here in this case we will be having only one K map for Y. So we have three input variable. So three input variable, this is A as the input, B and C. Here we will be having 0 and 1. Here we have 0, 0, 0, 1, 1, 1 and 1, 0. Now we will see at what places we have to keep 1. Here we can even write the values as 0, 1, 2, 3, 4, 5, 6 and 7. So we can fill those places. For 3, we have 1. So here we can write 1. Then for 5, we have 1. So again, we will write 1. For 6, we have another 1. And for 7 also, we have 1. So these are the 4 places at which we have the output as 1. And therefore, we have 4 places where we have written 1 in the K map. So we will be having 3 groups of 2. One group, then we have second group, and then here we have the third group. So now the output Y will be equal to, for the first group we have B, C plus, for the second group we have A, C, and for the last one we have A, B. So this is the Boolean function for the truth table. And now on the basis of this Boolean function, we can draw the logic diagram. What would be the logic diagram? B into C is given to one AND gate. So from here we can give B, then C. Another AC can be drawn like this, that is A. Then C can be taken from here only, that is A. Then we have another AND gate for A and B. And then all the outputs of these AND gates will be given to a OR gate. And so we will get the output Y. So this is the combination logic circuit for the given problem. And this is the way we can design any combination circuit. That is, first of all, we will define the problem. Then we will draw the K map on the basis of the problem. Sorry, we will draw the truth table on the basis of the problem. Then on the basis of truth table, we will draw the K map. And then we will find out the Boolean function. And on the basis of this Boolean function, we can easily draw the logic diagram. So these are the references which we have used. Thank you.